Okay, here it is again, our total sum of square. Okay, and that is the total measurement error when only using y bar to estimate sales. Now, so our error, right, in our measurement, the deviation is going to equal this, yi minus y bar. So let's see if we can do better, right? Meaning explaining more of the deviation when we include xi, the student population. So our regression model is going to be, just as a reminder, again, yi equals beta naught plus beta 1 xi plus epsilon I. In another word, is sales hat, right? Which equals, excuse me, not sales hat, sales, right, equals beta naught plus beta 1 times the student population plus epsilon I. Now our estimated regression equation is expected value of yi, so expected sales equals beta naught plus beta 1 xi, or I should say the expected sales equals beta naught plus beta 1 times the given population, student population. Okay, so all right, our estimated regression equation is going to be y hat I equals b0 plus b1 times xi. And so how do we get our b0 and b1? Those are our estimators. So we're going to use our OLS method that we cover in the last handout. Right? And we're going to get that b0 equals this, and b1 equals summation xi minus x bar, yi minus y bar. Okay. All right, so once we got that, now we already did the calculation on the last handout, and so you remember this is what we got. So through using these two formulas and the data set, we got these two. So then our estimated regression equation equals 60 plus 5 times xi. Okay, all right, now let's graph that. So here we got our estimated regression equation, and just approximately 60 is probably about there, about here. There, that's our equation. Now let's take a look at the deviation now, okay? Because this is still not a 100% accurate prediction. How do I know that? Because the observations are not all on this same line. So by including this, right, we are still off, right? The predictions are all still off a little bit. Okay. However, right, we can clearly see here we have done a much better job. Right? Let's compare that. I'm going to use a different colored pen here. Let's compare that to how we did when we were using just y bar. So again, y bar here, 130. Okay. So here again, here's y bar equals 130. Okay. And then here is our estimated regression equation, which is 60 plus 5xi. And look at the deviation. So the red here now is going to be the deviation from the mean. Okay, and that is your SST. Okay. And you can clearly see here the deviation from the blue line is much less than the deviation from the red line. Right? So what we can conclude, just at least visually here, right? We can say that by adding population into the model, we explained much of the total deviation. Here's a better picture from the book comparing comparing the estimation using just y bar versus using our estimated regression equation. Right? And we're going to see here the total deviation, which is, let's see here, right, can be broken down into two parts. Okay? Now, yeah, right, this line here, let me just write y hat. This is our y hat I equals 60 plus 5xi. Right? It still missed a little bit, right? There is still some measurement error. So this here, all right, that is still the remaining error, which we will call EI. But this part here, that is the explained part, right? That is explained by the regression. So we have Again, yi minus y bar. This is the total, right? Total deviation. Now we have our yi minus y hat I. This is our estimated regression, right? And this is our error. Right? Or we also have a different name for it now, where we call this the residual. It's the same thing. Right? Well, different name, but they represent the same thing. This is our residual. Then what's left? Well, y hat I, that's the line here, minus y bar. Right? That is the explained, or they will call that the explained deviation from the mean. Oh, sorry, explained deviation by the regression. Excuse me. Right? By the regression, by introducing, right, by population. Okay, let me illustrate how much better we did. Suppose that the student population is 26,000. Okay, what is the expected quarterly sale? So now we can use our model to try to estimate this. If I'm using y bar only, remember, y bar equals 130. And if I want to use y bar to estimate, to make this prediction, then the best I can do, y hat, is simply 130. Right? I have no other piece of information. I can't utilize this because this is not in my model yet. So my y hat is 130. Okay. All right. Now, what is my what's my deviation? So here we go. My yi minus y bar, which equals. Now I have the deviation. So I have 26,000. Now if I look at my previous page, so we do have 26,000 here, and we know that if a restaurant with 26,000 student population, we know that the observed is 202. So let's write that down here. 202 minus 130. Okay, now 130, and that's going to give us 72. So our error is 72 from this model. Now, what if we estimate using the estimated regression equation? Remember our y hat, right? Y hat I equals 60 plus 5xi. So my y hat is going to be 60 plus 5 times 26. I've included in the model, and here is 190. What's my error? Well, my y minus y hat equals 202, again that's my observed, minus 190. That equals 12. So now my measurement error, my prediction error, is 12. Okay, so I'm doing much better than what I did before. Okay, so how much total deviation of sale was explained? Well, we need to complete these different measurements. So we already talked about SST. Let me write it again here. This is the total sum of square. SSE, this is the sum squared errors. Right? And now this is not uniformly always the same name. Some program called it the residuals. So which one makes it confusing? Different softwares, different textbooks might switch the names around a little bit, but for now we're going to call it SSE, sum of square errors. SSR is sum of square regression. Okay, mathematically, we saw this before already. This is yi minus y bar square, observed minus the average. Here is yi minus y hat I. So this is the error in our measurement. Okay, and then finally here then is summation of y hat I minus y bar squared. Now, interpretation, right? This is total deviation from the mean. Right? This is total error in the model, because this is still the part that's not explained yet. Well, then what's left over here? Then this is total deviation explained by the model. Again, whenever we say model, we're talking about the regressor, all right, or an independent variable. All right, there we go. Now, there's a relationship between these three measurements. That is, and this is the most important part here, SST equals SSE plus SSR. Total deviation equals the error unexplained plus the explained. Let me write that down here. All right, and there we go. So in the next video, I'm going to show you, using this example, how to use Gradle to generate all three numbers.